Look up at the night sky. What do you see? Is it just a dark canvas dotted with tiny lights, or is it something more? A dazzling tapestry of stars, right? Each one twinkling like a diamond, forming patterns and constellations that have guided sailors and inspired dreamers for millennia. Each one a fiery ball of gas, shining brightly across unimaginable distances. These stars, though they seem so small from our vantage point, are colossal furnaces burning with intense energy. But have you ever wondered where these celestial wonders come from? How are stars born? What processes lead to the creation of these magnificent beacons of light? The answer lies in the heart of giant clouds of gas and dust scattered throughout the cosmos, the stellar nurseries we call molecular clouds. These clouds, often invisible to the naked eye, are the cradles of star formation. These cosmic clouds are the birthplaces of stars, the starting point of a magnificent cosmic journey. Within these clouds, the seeds of stars are sown, waiting for the right conditions to ignite. The birth of a star is a tale of gravity, heat, and light, a complex interplay of forces that transform simple particles into brilliant suns. It begins with the slow collapse of a region within a molecular cloud, pulled together by the relentless force of gravity. As the cloud collapses, it heats up, and the pressure increases. Over time, the core of this collapsing cloud becomes so hot and dense that nuclear fusion ignites, and a star is born. This cosmic dance has been unfolding for billions of years, creating the stars that light up our night sky. It's a story that connects us to the universe in a profound way, reminding us that we are part of something much larger than ourselves. The atoms in our bodies, the very elements that make up our world, were forged in the heart of stars. For the very elements that make up our bodies were forged in the heart of stars. Elements like carbon, oxygen, and iron were created in the intense heat and pressure of stellar cores, then scattered across the cosmos when stars exploded as supernova. Join me as we explore this incredible journey, tracing the life cycle of stars from their birth in molecular clouds to their eventual demise. We'll delve into the mysteries of star formation, uncovering the secrets of the universe one star at a time. From the cold, dark depths of molecular clouds to the brilliant light of a newborn star, this journey is a testament to the beauty and complexity of the cosmos. So, let's embark on this adventure together and discover where stars take their first breath. Imagine a cloud so vast it could swallow our entire solar system thousands of times over. These clouds are not just any ordinary clouds. They are the birthplaces of stars, the stellar cradles of the universe. They stretch across light years, encompassing regions so immense that they boggle the human mind. Within these colossal structures, the seeds of stars are sown, and the story of our cosmos unfolds. Now, picture this cloud not as fluffy and white like those we see on Earth, but dark and dense, filled with gas and dust. These clouds are so thick that they block out the light from the stars behind them, creating vast regions of darkness in the sky. Yet, within this darkness lies the potential for light, as these clouds are the nurseries where new stars are born. These are molecular clouds, the cosmic wombs where stars are conceived. They are the cradles of creation, where the raw materials of the universe come together to form new celestial bodies. Within these clouds, the process of star formation begins as gravity pulls the gas and dust together, creating dense regions that will eventually ignite to form new stars. They are cold, some of the coldest places in the universe, and dark, obscuring the light of stars behind them. Temperatures in these clouds can drop to just a few degrees above absolute zero, making them some of the most frigid environments in existence. Despite their coldness, these clouds are teeming with the potential for new life, as the elements within them come together to form new stars and planets. Don't let their darkness fool you, though. Within these clouds, a hidden world of activity is taking place. The gas and dust within them are constantly moving, colliding, and interacting, creating the conditions necessary for star formation. These clouds are dynamic, ever-changing environments where the forces of nature are at work, shaping the future of the universe. Molecular clouds are teeming with activity. Within them, the process of star formation is constantly underway as gravity pulls the gas and dust together, creating dense regions that will eventually ignite to form new stars. These clouds are the engines of creation, where the raw materials of the universe are transformed into new celestial bodies. They are composed mainly of hydrogen and helium, the most abundant elements in the universe. These elements are the building blocks of stars, providing the fuel necessary for their formation and growth. Within these clouds, hydrogen and helium atoms come together, creating the conditions necessary for nuclear fusion to occur, igniting the birth of new stars, along with traces of other elements like oxygen, carbon, and nitrogen. These elements play a crucial role in the formation of stars and planets, providing the necessary ingredients for the creation of new celestial bodies. Within these clouds, the elements come together in a delicate dance, creating the conditions necessary for the birth of new stars and planets. These elements are the building blocks of stars and planets, the raw materials from which new worlds will be formed. Within these clouds, the process of creation is constantly underway, as the elements come together to form new stars and planets. These clouds are the cradles of the universe, where the story of our cosmos begins and the future of the universe is shaped. Within these vast, cold clouds, a delicate balance exists. These clouds, known as molecular clouds, are the birthplaces of stars. They are immense, stretching across light years, and are composed primarily of hydrogen molecules, with traces of other elements and dust. Despite their cold temperatures, often just a few degrees above absolute zero, they are teeming with potential energy. Gravity, the force that holds us to the Earth, is constantly trying to pull the gas and dust together. This relentless force is always at work, attempting to draw every particle closer to the center of mass. It's a silent, invisible hand that shapes the universe, from the smallest grains of dust to the largest galaxies. However, the cloud's internal pressure, a result of the particle's random motion, pushes back, preventing a complete collapse. This pressure is generated by the thermal motion of the particles, each one moving in a seemingly random direction, creating a counterforce to gravity. It's a cosmic tug-of-war, with gravity pulling inward and pressure pushing outward. But this balance can't last forever. Over time, the delicate equilibrium can be disturbed. The cloud may cool down, reducing the internal pressure, or it may encounter external forces that tip the scales in favor of gravity. Imagine a gentle breeze turning into a raging storm. Just as a calm day can suddenly give way to a tempest, the serene molecular cloud can be thrown into chaos by external influences. Something disturbs the peace within the cloud. Perhaps the shockwave from a nearby supernova, a cataclysmic explosion that sends ripples through the fabric of space. This shockwave can compress parts of the cloud, triggering the collapse. The gravitational tug of a passing star, which can create tidal forces that disrupt the cloud's stability. As stars move through the galaxy, their gravitational fields can interact with molecular clouds, causing regions of higher density to form, or even the collision of two clouds. When two molecular clouds collide, the impact can compress the gas and dust, leading to the formation of dense regions where gravity can take over. This disturbance creates areas of higher density within the cloud, places where gravity gains the upper hand. In these denser regions, the gravitational pull becomes stronger than the internal pressure, initiating the collapse. And so begins the magnificent collapse of a molecular cloud, setting the stage for the birth of a star. As the cloud collapses, it fragments into smaller clumps, each of which can form a new star. The process is slow, taking millions of years, but it is the beginning of a star's life cycle. From the chaos of collapse comes the order of a new star, shining brightly in the cosmos.